Francisco and Issufo, Floating Orbit Theory, 2025. New Atomic Theory, Francisco and Issufo, 2025. In 2025, two young Mozambican thinkers, Francisco Cosme Nguereca and Issufo José Nahaia, proposed a new way to understand the behavior of electrons within the atom, the floating orbit theory. 1. Introduction. Throughout history, many scientists have tried to explain the structure of the atom. One of the most famous was Niels Bohr, who in 1913 stated that electrons move in fixed orbits, jumping from one orbit to another when they gain or lose energy. However, Francisco and Issufo saw a different and smoother possibility for this phenomenon. 2. What the new theory proposes. According to the floating orbit theory, 1. Electrons revolve within orbits around the nucleus, as Bohr originally suggested. However, these orbits are not fixed. They float gently, moving in response to invisible forces inside the atom. 3. These forces include subatomic influences and the very gravity of the nucleus. 4. When there are energy variations, electrons do not jump to a different orbit. 5. Instead, the orbit adjusts, moving like a flexible and living cloud. 6. Thus, even a seemingly stable atom is in constant internal motion. 3. Comparison with Bohr's theory. Aspect, Bohr's theory. Electrons jump between orbits. Francisco and Issufo. Electrons stay in the same floating orbit. Shape of the orbit. Bohr's theory. The orbit is fixed and well-defined. Francisco and Issufo. The orbit is floating, like a cloud. Reaction to energy. Bohr's theory. The electron changes orbit. Francisco and Issufo. The orbit adjusts internally. 4th, illustrative example, the sky, clouds, and subatomic wind. Imagine the world as the nucleus of an atom, with the clouds representing the electron orbits. If there were no invisible energy, no wind, the clouds would remain fixed in the sky, just as the orbits would stay fixed around the nucleus. However, what really happens is that there is an invisible subatomic force, like wind, making the orbits, clouds, move continuously, even without sudden jumps. So, the orbits are not fixed. They float gently, adjusting to energy changes, like the wind moving clouds in the sky. 5. Conclusion. The theory proposed by Francisco and Issufo provides a more fluid and natural view of the atom, respecting scientific principles, but going beyond classical ideas. They show that science can also emerge from curiosity, observation, and boldness, even outside of big laboratories. 6th final observation. The floating orbit theory still needs to be tested and further explored by the scientific community. However, it already stands out as a powerful example of how new ideas can emerge from anywhere in the world, including a humble neighborhood in Mozambique. And for the closing part, so what do you think of these young minds? Do you believe that Mozambique will have new scientists shining in the future? Stay tuned, because the future of science is just beginning, and who knows what else we will discover together. If you enjoyed this, don't forget to subscribe for more curious ideas like this. See you next time.